Hey y'all, in this lesson, you're going to learn about slope or average rate of change. The steepness and direction of the slant of a line is called slope. Slope is used to find the average rate of change between two variables. For example, miles per hour, feet per second, the pitch of a roof, steepness of a road, anything that's going to be linear in nature, and you're trying to find how much it's changing over a certain amount of units, time, or distance, whatever, is slope. Slope can be found by charting rise over run on the graph. This is geometrically, so that's like counting squares, or using the slope formula. That's an algebraic method. We use the letter lowercase m for slope when using the formula. So you can find the slope between any 2 points, x1, y1, and x2, y2. That's 2 points written as x comma y, where the first point is x1, y1, and the second point is x2, y2. And then you can find the slope of that line by charting rise over run, which geometrically is finding the change in our y values over the change in our x values. The change in y, that's responsible for up and down, which is rise. And then the change in x is responsible for side to side, which is run. And then in algebraic form, what that means is we are subtracting our y values divided by subtracting our x values. So that's just 3 different ways to look at slope. We can look at some just general pictures of linear equations to talk about the sign, the positive, negative, 0, the sign of the slope, just so you can kind of narrow down and troubleshoot. So if a line is rising from left to right, it doesn't really matter where you draw your line. We're just trying to show an example of a line that's rising. So if you were to put a little car on this line, it would be going uphill. This would have a positive slope. So the m value would have to be positive. If you found the slope algebraically and you came up with a negative number, then that's how you know you did something wrong. So the general equation for this would be y, make that smaller, equals mx plus b, where m is a positive slope. A negative slope line will be falling, so going downhill. And again, it doesn't matter where you draw this line, as long as if we had a little car, a round car, I don't know, a rock, a ball, a marble, whatever, it would be falling downhill. And this is the line of a negative slope. So we would have a negative m value right here. Negative slope. Now, these equations that I'm writing, these are in slope intercept form. That's not necessarily what we're trying to focus on for this lesson yet, but it is a good seed to be planted for later when you're writing equations of lines. You will become very familiar with these forms. Next one, a 0 slope. That means no slope. If you think about the same theme of uphill and downhill, then something with no slope would be a flat line. And again, you can draw that anywhere. So if it was a car, it would be just driving flat, no hills. And this is in the form of y equals a number. So there's no m because m is 0. And so we don't really have an m. Well, we do, but it's 0. And 0 times x is just 0. So we end up with y equals b, which is a number. But this would be fine. This or this would be fine to write as the equation of a line that looks like that. And then the last scenario, we have an undefined slope. This will be straight up and down. And if you think about a car again, a car is not going to be able to scale that mountain. And so this is undefined. And what's happening here is, for example, we're going, if I started here, we're going up 1 over 0, up 1 over 0, up 1 over 0, up 1 over 0. You get the idea. And anything, anything over 0, we can't divide that. There's not a number that exists to make that true. We call this undefined. And when we end up with 0 under the fraction bar, that's an undefined fraction, which means that the slope is also undefined. And the equations of these lines are going to be in the form of x equals a number. There's not going to be a y variable in the equation. Now, there are y coordinates to each of these points, but as far as writing the equation of the line, it's just x equals because it goes straight through the x-axis. When it's y equals, it goes straight through the y-axis, or y equals a constant, sorry. So that's the 4 scenarios that you will come across with slope. So let's look at this example here. Find the slope geometrically and algebraically. So we're given this picture, and geometrically means rise over run. Rise over run. We do know that this line is either going to have a negative or a positive slope depending on the slant and direction. So if we put a marble at the top of the picture, that marble is going to be rolling downhill, which means that this will have a negative slope. This indicates that whatever value we get here and here, it should be negative. If it's not negative, then you've done something wrong and you have to go back and check it. A lot of times with algebraic methods, negative sign dropped or added in accidentally, and you just have to go back and check that. It's a very simple mistake to fix. Geometrically, you can pick any point on the graph because this is going to have an average rate of change, a constant rate of change. It's linear. So for every unit, it's going to move at the same rate. It's going down and over, down and over, down and over, down and over, over and over and over and over again. And depending on what you see first, you just pick any point on the graph. Ideally, what you're going to want to look for is where the graph goes through nice and neat on those crosshairs. So this will be a good spot. This looks like a good one. This looks like a good one. This one. So there are decimal, values in between those nice, neat crosshairs, but we want to try to keep it as simple as possible and look for those specific places where we have a very clear point. I'm going to make that pink so we can see it better. So here's one, and here's one. And geometrically means that I'm figuring out how many units that the graph rises first and then runs. So to go from this point to that point, I have to go up a certain amount and left a certain amount. Or if you had started with this point, you would have to go down and right. In either case, you're going to end up with the same slope once you simplify, once you reduce, because it's a constant rate of change. And so whether you see it this way or this way, it's the same amount of units. So it doesn't matter. And your signs, your negative sign may be in the top or the bottom, but it will be in one or the other, depending on the scenario that you used. For this one, I would go up 1, 2, 3, and I would run 1, 2, 3, 4 to the left. Left means negative. And so in my example, the negative is in the bottom. We don't typically write a negative in the bottom. Usually you're going to see it just out front or in the numerator, but it really doesn't matter. But you'll probably not see it in the bottom. If you had chosen to start with this point instead, we would go down 1, 2, 3, -3, over 1, 2, 3, 4, +4. So you still end up with that -3/4 in both cases. That's geometrically. That's rise over run. And you could have picked any 2 points to chart that. And if it helps, I do the little jumps. I like the jumps because it shows how many times you jumped. If it helps, you can do draw this triangle, and it's the length of each leg on that triangle. This goes down 3, right 4. That works too. Same thing though. Algebraically, we're still going to use these 2 points. Whatever 2 points you picked is fine. I picked 0, 2, and -4, 5. Let me make sure. I've marked all over it, so I just want to make sure I did that right. 1, 2, 3, 4, 5. Yep, -4, 5. So I have chosen 2 points on. This is x1, y1, x2, y2. Now, if you had written your points in a different order, then you'll have a different x1, y1, and x2, y2, but we will end up with the same answer. Your sign, again, your sign might be on the numerator versus the denominator or vice versa, but we should still end up with the same answer as long as we're doing it correctly. And then I'm going to use my formula. I'm going to continue down here. y2 minus y1 over x2 minus x1. And then I just sub it in. y2 is 5. Minus is part of the formula. y1 is 2. x2, which is -4, minus is part of the formula. x1 is 0. So this is really important that you know that these minuses, these subtraction signs, are part of the formula. So even if this second number is negative, it wasn't in our case, but even if it was, yes, you would have the double negative, and that changes to a positive. So you will definitely see that when you're looking at slope. Just make sure that you don't drop that minus that's part of the formula. It will make a big difference. And then we simplify 5 minus 2 and -4 minus 0. Does that look familiar? It should. So -3/4. When we're talking about slope, we leave it in fraction form. We want to leave it in fraction form because it's giving us a roadmap. It's telling us directions, where to go. And so fraction is perfect. We leave it and we're done with slope. That's all I have for slope. If you have any questions, please let me know and I'd be happy to help. See you in the next one.